One subtopic in vector space, Wronskian, linear independence of a function. Okay, so what is linear independence? Okay, let's say we have a vector space V. Okay, and then we have a set S, two vectors. Okay. So V1 and V2 or the set S is said to be a linear independent set if V1 and V2 is not combination of each other. V1 is not alpha V2, V2 is not alpha V1. Okay. So now what is Wronskian? What is the relation between Wronskian for linear independence? Okay. So first of all, what is Wronskian? Okay, let's say we have n functions, okay, several functions, f1, f2 until fn are functions, okay, and then all of these functions are differentiable lah, okay. So the Wronskian is the determinant, okay, the determinant of this function and derivative. If you have four functions, f1, f2, f3, f4, the first row is the functions, okay, and then the second row is the first derivative of the function. If you have n function and you have to differentiate n minus 1 times, okay. If you have three functions, you have to differentiate twice, okay. If you have four functions, you have to differentiate triple differentiation. To find the determinant, the matrix must be squared. So the first row, the function itself, differentiate less 1 from the total number of the functions. Okay, so this determinant is called the Wronskian. If the Wx ni, the Wronskian is not equal to 0, okay, dalam interval ni, okay, maybe at some point the Wronskian 0, not all points. Okay, first example. Okay, let's say we have two functions, f1 equals to 1 and f2 equals to sine x. Use the Wronskian to show that these functions are linearly independent vector. Okay, the vectors are functions. Okay, so in this interval of any real number lah, from negative infinity to infinity. Okay, so Wronskian, two functions. Therefore, the matrix will be 2 by 2. Okay, the first row of the matrix is the function, and the second row is the first derivative. So f1 is x, f2 is sine x, differentiate x, differentiate sine, cos. X cos x minus sine x. Okay, so this is the Wronskian. If Wronskian not equal to 0, so the functions are linearly independent. But if the Wronskian equal to 0, we cannot make any conclusion. So how to decide whether this Wronskian 0, substitute any value of x. For example, x equal to 0. 0 in this range. 0, cos 0, sine 0, 0. The Wronskian may have 0 value at certain point. X equals to pi, but pi, cos pi minus sine pi, Wronskian is negative pi. The function is linear independent because the Wronskian is not identically 0. The functions f1, f2 are linearly independent. Three functions, f1 equals to 1, f2 equals to exponent x, f3 equals to exponent 2x. The three functions, second derivative. Okay. So we have three functions. So the matrix 3 by 3. To determine this matrix must be squared matrix. So the first row is f1, f2, f3. The second row is f1 prime, f2 prime, and f3 prime. And then double prime, double prime, double prime. So f1 is 1, f2 is exponent x, f3 is exponent 2x, column by column. Differentiate 1, get 0, and then differentiate 0, you get 0. Okay. And then the second function is exponent x. Differentiate exponent x is exponent x. And then differentiate exponent x, another exponent x. Okay. So f3 is exponent 2x. Okay. Differentiate exponent 2x, the Wronskian is 2 exponent 3x. Okay. X equal to 0. So this function is 2 exponent 0. Exponent 0 is equal to 1. 2. The Wronskian is 2. So Wx is not identically 0. The functions are linearly independent.